If you haven't heard of our Tech Person of the Week, we just choose, it's a recurring segment in our meetings where we choose to highlight someone in tech that isn't highlighted as much and talk about them. So Gigi can take it away with our Tech Person of the Week.
Yeah, so for Tech Person of the Week for this week, I chose Meredith Whitaker. So she is the co-founder of the AI Now Institute and also the organizer, or she was one of the organizers for the Google walkouts in 2018. So like I said, she's the co-founder and co-director of the AI Now Institute at NYU. And they're a leading institute dedicated to researching the social implications of AI and related tech. So looking into like algorithmic bias, things like that, and ways to minimize that impact. And then she was also one of the core organizers of the Google walkouts in 2018. So during those, over 20,000 Google employees walked out in order to shed light on Google's dismissive culture with regard to claims of sexual misconduct and citizen surveillance.
Thank you for that, Tech Person. Like, I always love seeing who everyone chooses, and this one's a really good one. So to start us off, Sumana, do you want to talk a little bit about, I know the word database can be daunting to a lot of people.
Yeah, so basically everything in SQL is related to this idea of a database. And a database is a collection of data that's organized in a specific way that lets you show connections between different types of data. If you can click again, I think there might be an animation for some little diagram. Yeah, okay. So a simple way to collect data is to make Excel tables. But if you have, for example, a bunch of musicians, and each musician has all of their albums and release dates and ratings, and each album has a bunch of tracks. So now you have a bunch of artists, each with a ton of albums connected to them, and each of those connected tracks have all their info, like song name, length, and more. So it'd be really difficult to represent all of this in like an Excel table. So we use a database which allows you to have multiple tables with connections between them. So like an artist table with artist data entries, and each entry can have a connection to an album and an album table. So basically, whereas Excel might not let you show connections between lots and lots of tables, a database will let you do that.
Mm-hmm. Another cool example that helped me understand what a database is that's pretty relatable is, think of a school, kind of like just like Northeastern. Each student has a set of information that's stored about them. Each professor has a set of information stored about them. And then one thing that could connect those two is, let's say, courses. So each professor would teach a certain course, and then there's a list of students in that course. So that's just kind of a way to relate those two with their own database, with their own tables, to one table. So kind of introduction into MySQL again. So SQL stands for structured query language. You do not need to know that at all. Just a little fun fact. But it's basically the way, just like any coding language, just how you guys have done, whether it be Fundies 1 or Fundies 2, it's your way to communicate with, in your case, it's just like your way to communicate with the computer. In this case, it's your way to communicate with the data in each table. The most important things you need to know when talking to a database is select, insert, update, delete, and create. The one in bold is the only one we're going to be mostly using today. We're not going to do any inserting, updating, deleting, or creating. Select is the one that's basically like, hey, I want that. So get me that from the database, and you pick your constraints on how to do that, and we'll walk a little more through that later. These are also referred to as CRUD operations. You've probably heard of them in a lot of other classes. I know it came up in web dev, but it's just create, remove, update, and delete, which is basically what you need to alter and collect data. Also, a few data types. You guys have, these might seem familiar from any of your classes that you've taken. An int is literally int, number, big int if it's a really big number. You don't need to know these specifics. Boolean or tiny int are the same. They're kind of how you use true or false. And then an enum, you can think of it as a dropdown. So it's a collection of limited types. So back to the school or even like musician analogy, there can be a list of instruments that you play. So what instrument do you play? And then you put those limited amount of instruments in there and you can pick from those. And then varchar is just can be a combination of numbers and letters. And char is strictly what you guys might know as string, which is just letters. And then date, which you'll be working with to find the clues in the competition, is again the date, but it has its own type because dates are formatted a certain way in MySQL. So this is the syntax that that we'll probably be using most throughout the competition, and then we'll explain a little bit. Like I mentioned, I'm going to quickly go through them and then we're going to walk through some of them specifically as we go on. Select is your way of saying get, just how you would get anything from, just how you'd use get in Java. I don't remember what the one from Funny's one is, but there probably is like some form of give me. You're basically saying, I want that, return that to me. From is the table you're picking from. So if we're going back to the musicians table, you could just be like, from the instruments table, I want this instrument. As is the way of setting a variable. So you could just say, I want this to be called blank. And then you can refer back to that as blank the whole time you're using in the scope of that select statement. Star, again, I'll explain more with the table, with an actual drawing, but it's basically saying, give me everything. And then where is the way is like using an if statement, how you'd do a conditional. Again, we'll walk through that. And then or and are probably very familiar, but you could just be like, I want the fruit that's red or orange, and then you can get fruits that are red or orange. Count we won't be using much of in this, but it's basically your way of saying, give me the number that's associated with the database. So for students, we could just be like, give me the number of students at Northeastern, and then you could just put count star. Like is like a pattern, is a way to pick up a pattern. A join, we'll walk through one concrete example of that, but it's your way of connecting two tables together. So going back to the student one, you want to connect, you want to find out which students are in specific courses. You can basically join those two tables together and get your results from there. Distinct is just removing any duplicates from any tables, and then operators you're familiar with. Order by is a way of sorting. You could do it by ascending or descending order. And then group by is your way of, it's similar to getting rid of duplicates, but let's say you have a list of students from the same country and you just want to get how many students are from the country. You could just say group by country and it'll give you the number of students in each country. Order by and group by are different because order by just orders the list you have. Group by removes any or like combines any duplicates in that sense and gives you the aggregate of them. And then limit is, you'll probably have to use this one, hint, hint. It's limiting the answers that you get from there. This is a lot of, basically like a dictionary of any SQL syntax you would need. Can someone share that in the chat actually? But Google's very much your friend throughout this entire competition. Please, please, please use Google for syntax help. A lot of it kind of sounds like English, so it's self-explanatory in that way. It can be a little hard to translate like English to like directly SQL, but for the most part, any syntax can be found at this website. And we can put it in the chat also before we start the competition.
Before we move on, Gigi asked a question in the chat about what you mean by aggregate or aggregate.
Yep. It's just a combination of, let me go back to that. So let's say it's a way to combine results. So like the example I mentioned, you want to find the total number of students from each country. You have a table of students. We can go through one example of like what that means to combine in our student table down the line, but you basically want a combination of students from that country. So you're combining those together and then group them by country. Does that clear it up a little more? All right, we can also go through more examples of that. So this first example is without anything else, like I mentioned. Let's say in this table, again, we're thinking of databases like tables. In this table, I want the fruit ID, just the fruit ID. So I'd say select fruit ID, and then this is what I get. However, this isn't complete yet because we need to pick which table we're getting from, which brings me to the next part. So let's say this is called the fruit table. So I'll say, give me the fruit ID and fruit name from fruit table. So this is what you would get from that select statement. Give me fruit ID and fruit name from that table. If there was a different table, you could also just change and do from music table or from instrument table. Like I mentioned earlier, star just gives you everything. So similar to the last statement, instead of saying, give me fruit ID and fruit name, you could just say, give me the entire fruit table. I want everything in there. And that's how you would count everything in the fruit table as well. So say, give me count everything from fruit table. And that's going to give you, the reason that gives you 2 is because there's 2 entries. So this is one fruit and this is the other fruit. You can also think of them as rows. The columns are the fields and then the entries are the rows. Naming variables. This is what I mentioned earlier in as. You could do select, depending on what column you want, you could have it be fruit ID as fruit 1. So now every time you want to use that column, you can just say fruit 1 dot whatever the field is there, and then just reference it that way. And similarly here too. So if the word's too long, you don't want to keep having to write dot or having to write customer transaction ID every time. You can just name that, or customer transaction table, you can just name that as blank and then just reference blank throughout the whole time. This one is a little different because this one you're returning it as. You can also do that. As can also be name it this when you're returning it, or it could just be a variable that you're referencing and then returning later. Fruit name from fruit table. This is the if conditional that I was talking about earlier. So this syntax is basically saying, give me a fruit that ends in R. You can also do, and then like is just the one that's picking up on the pattern. So give me the fruit name from the fruit table, like we mentioned, the conditional statement where fruit name ends in an R. You could also do start in R, or you could do an exact name where you could just like give me orange. So you write equals just the equal operator orange. You can use this link to get to the slides to go over any of like the specific select statements that we went through. I can also put it in the chat at some point. But if you want to go to that, you can access what we just talked about there. Okay. So this is just a more concrete example of, again, what I was talking about, but with actual values, not just fruit ID and fruit 1 and 2. So this is a student table. It has a lot of fields. It has student ID, student name, college ID, high school ID, year, and then this is whether they graduated or didn't graduate. Some of these aren't true. I just made some of these up. But if you want to return this whole table, you would just get student or select star from student table, and you just get this entire table. And then if you want to count, similarly to how we mentioned before, select count star. This will give you 1, 2, 3, 4, 5. And then student name. Does anyone know what that would return? I'm curious. If anyone, what would you just get if you select student name from student table? You would actually just get, since you're not saying select star, you wouldn't actually get this entire table, but you would just get, I don't know if someone said it in the chat, but you would just get this column of everyone's name.
Would you get the entire column, or do you have to do star to get the whole column?
Nope, you just have to do, if you select student name, it's going to give you all the student names from student table. If you select star, it'll give you every column and every row. Or every row in this case. But if you want one column, you could just say select college ID too, and it'll just give you college ID.
Okay, so the asterisk or the star is an alternative to the specific name of a column?
No, actually, so it just gives you every row. So every entry. So it's just like, it's a way of saying, give me every single entry we have in this database and just return that. And it just labels them with the columns, but it's not actually returning each column. It's more just returning every entry. And that's how it counts them as well, because it wouldn't count the columns. It would just count how many entries are in each table.
Yeah, it like just literally gives you like everything.
And then this is a more specific, again, another conditional. So now instead of returning the whole table, what do you guys think this one would return? The reason college ID and high school ID aren't unique as opposed to student ID being unique, this is going to be a very important question when it gets to the harder level questions. Student ID needs to be unique because you can't have more than one student, and that's your way of referencing that student. With college ID, you can say Vincent, Brendan, Gigi, and Chloe go to the same college, and Baden's college ID is different, so she goes to a different college. Same thing with high school. So Gigi, Chloe, and Vincent went to the same high school. Baden and Brendan went to different high schools. So what do you think selecting student name from student table where high school ID 3212 would return? Which student names would that return? Again, I'm not looking at the chat, so someone needs to tell me if someone gives the right answer.
Yeah, Anna answered in the chat that it would be Vincent, Chloe, and Gigi.
Perfect. On your way to being the Sherlock Holmes of SQL, Anna. Very proud of you. So in this case, it's very similar to the last one, except we've introduced an or. So select student name from student table again, where high school ID is 3212 or high school ID is 4812. So in this case, the only person who wouldn't be in the select statement, wouldn't be outputted from the select statement is Baden, because or would combine the results from 3212 and then also the high school ID 4812. So we pick everyone except Baden. Another cool trick is you can pick more than one field. you can, if you want to return the student ID and college ID for everything, you could also do student ID, student name, college ID, high school ID, year, and graduated, which again, you can just do star for that. But if you just want to pick two, you could do student ID and college ID, year, you're picking year from student table where college ID is 202 and they graduated. So in this case, which row would be returned?
The fourth?
Yes, perfect. We would return Gigi because she graduated and her college ID is 202.
Well, we wouldn't return the whole row, right? We would return just like
yes.
student ID, college ID, and the year.
Yep.
Row 4.
That is correct. So we'd return this, this, and year. So we would return these for graduated. And then if you want, let's say you wanted to count the number of people who haven't graduated, you could do, going back to the star, select count star from student table. So this whole thing is going to be like, give me the whole table. The part where we're filtering out, I guess, is just where at the where. So where graduated equals 0. So it'll go through and get the whole table and be like, oh, no, I want the ones where graduated here is set to 0. And then this, we kind of went through an example of this with fruits earlier. Let's say we want to pick a name that starts with V. This is how we would do that. We'd say, select the whole row from, so again, this would return the whole row in this case, from the student table where student name is like, since it's the pattern recognizer, starts with a V. So in this case, you don't have to do this statement to know it, but we would tick Vincent. So we just return this entire row. Kind of went through this already. I'd rather explain it on the presentation. So this is just the idea of primary keys and foreign keys. Primary keys have to be unique, like I mentioned with the student table. And you can't not have a primary key because it's your way of identifying the students in that table. And then foreign keys are, like I mentioned, with the college ID and high school ID, are basically references to other tables. And then foreign keys usually, I'm going to go back to the table, but foreign keys usually play the role of a primary key in another table. So if you had, in this case, if we had a student table, this is the student table. If we had a college table, it would just be like Northeastern is 202. So college name, Northeastern, college ID is 202. And then you can't have another 202 if you're talking about BU or Harvard, then those would have to have different college IDs than 202. But then those are the unique identifiers of the college table, but you can reference them from the student table, which you won't need to work with. Most of our questions come from one table, so you won't need to get the idea of joins down, but basically that's it. So before we hop into the competition, I want to walk through one example from the bulk of the competition is coming from this database. So like we mentioned, this is just a table with, you can consider these as fields since most of you are comfortable working with that idea. So there's a title, year, summary, short summary, genres, runtime, just how long, IMDb ID, runtime, YouTube trailer, rating, movie poster, director, writers, and cast. Those are the fields. You won't have to like access all of the fields, but kind of how writing a query would be in this case. In this case, we're selecting both rating and title from, this is what the table is called. So Hydra Movie Scrape. and then group by rating. So if you look at this, if you look at these ratings, the ratings don't duplicate. So you wouldn't see 6.6 again. It's just picking the one. So Twilight, sadly, Eclipse. I thought that was better than a 5, but sure. Just the rating was 5. If we were to do order by and then rating, and then let's pick ascending, and we run this, it would go from the lowest rating. So it would give us the rating title from all movies, and then there are duplicates in this case. It would just be showing them in ascending order. And we can also do, I think this is descending. Yep. So the highest rated movie, and then it works its way down. So this is an example of the database that you guys are going to be working with, and what you're going to have to find. Most of the time, you're going to be finding one field, so you won't need the comma. Any syntax that you want me to walk through on this database before I move on to like talking a little bit about joins? Is that a no? Yes, I can't really read the chat. Okay, so going to joins a little bit. So for the joins, for the easy to medium questions in this competition, we're going to be mostly using that database. For the harder questions, we're going to be using multiple tables. So like we mentioned earlier, they're just like these tables that exist in the database, and then there's ways that they are connected. Just looking at the customers and transactions tables, customers have their ID. So let's say we're looking at John Steinbeck. That is, his ID is number 9. So let's say we go to transactions. This kind of just looks like numbers, but we see customer ID, which we recognize. So we're like, okay, so John's customer ID was 9. So let's look in transactions and see. We're not looking at this one because this is the primary key for transactions, but we're just looking at customer ID. And we want to find out which ones, if John made any purchases or transactions. So here, John would be 9, and then we can see the transactions that he made. So 25, 26, 27, and 28, and 29 are transactions he made, and he made them on these dates. So let's say we want to kind of looking at this whole part is just saying, so combine these tables. To join two tables, they have to have a similarity. So in this case, they both have customer ID as a similarity. Customers has ID as a primary key, which it points to the transactions, and then it's also there in the transactions table. So in this case, we're joining on the customer ID. So as I mentioned here with the variables earlier, so it's as customers from customers as C. So we wouldn't have to refer to customers every time we want to call customers. So select blank from the customers table as C, and then join that, combine those with transactions as T. Again, that's just a variable. You could just keep it as transactions and then do transactions.customer ID and then also customers.customer ID. So then this is kind of the table that you're picking from. You're picking from customers as C, and then you're joining that on their customer ID. So you're combining them with that similarity. And then the conditional after is where the date is equal to 2017. Again, the date is formatted like this, 2017, September 15th. And then again, instead of saying customers, I just do customer. dot last, and then it's kind of like you're calling that field. Should still run. There we go. Any questions about this? I know joins conceptually were very hard for me to grasp the first time I ever did joins. Cause like, what do you, this is like one table. So please ask away about joins or anything else before we get started in the competition.
If you do a join and like you want like star, what is that output exactly? If you like, I don't really know what would happen there.
Let's try it.
So I think, correct me if I'm wrong, but it'll get just the intersection of, it'll get the whole, all the information for the intersection of those two tables.
Yep. I like the way I think of it is that they're just combining those two tables together.
Sama, can you do one last very quick overview of joins?
I have a picture that I can use to kind of walk through that actually before we get started. Can everyone see this? This is just like conceptually high level. Again, you'll be more comfortable using them as you start to understand the idea of joins. So in this case, and again, we don't have too many questions about joins, so if you're not totally comfortable with them by the end of this, that's totally fine. Joins is when you have two connecting, so like if we're going back to the school example, we have students, there's a student ID in courses, and then there's also a professor ID in courses. But let's say we're leaving professors out, so we're just trying to find out which students are in what courses. So we basically is what you're doing is combining those two tables and then getting any information you want from those tables, whether you want to just count how many students are come up in the course table, you can do that. But the way I like to think of it conceptually is you're literally just combining those tables with the similarity that they have, and then saying on every student ID that you find in course tables, just find that one in students and then combine the tables, and then it gives you, it kind of like unlocks the information from both tables so you can access those. There's a lot of different types of joins, but the one that we're going with is the default join, which is the inner join, which finds a similarity and then combines the tables based on that similarity. Any more questions? I'm gonna take a look at the chat. Does this diagram kind of help a little bit?
Yeah.
Okay, perfect. So, anything that you want me to go over before I stop sharing my screen? Okay, cool. Is everyone ready to start the competition?